This presentation discusses and demonstrates the identification of sedimentary rocks. It follows previous presentations on sedimentary rock texture and sedimentary rock composition. Rocks are identified by their texture and composition. Texture relates to how the rock formed. Each rock family has its own set of textures, and a rock can have only one texture. Composition relates to what minerals or materials are contained within the rock. Sedimentary rocks are classified in three divisions: clastic, chemical, and organic. Clastic rocks are made of rock fragments. Chemical rocks are either precipitates or evaporites. Organic rocks contain animal or plant fossils. Clastic division rocks have clastic textures described as large, medium, fine, or very fine. The shapes are either rounded or angular. The textures of chemical division rocks are either crystalline, cryptocrystalline, or oolitic. Organic rocks have a fossiliferous texture. The components of sedimentary rocks are derived from other rocks and organic debris. Because quartz and calcite are very abundant, they are important constituents of sedimentary rocks. Quartz is resistant to weathering, making it more commonly found as rock fragments than calcite that readily dissolves. Clastic division sedimentary rocks are differentiated primarily by the size of the rock fragments that compose them, and are predominantly composed of quartz. Two rocks contain large or gravel-sized fragments. Conglomerate contains rounded gravel, and breccia contains angular pieces. 3 contain sand-sized pieces: sandstone, arkose, and greywacke. Greywacke contains angular fragments, and arkose contains at least 25% feldspar. Fine-sized particles, or silt, composes siltstone that does not readily break into layers. Clay-sized or very fine particles make up shale that usually breaks into sheets. Let us examine some samples of each of these. Conglomerate is a mixture of rounded rock fragments, including pebble-sized pieces. Quartz is the most common component of these pieces and the cementing agent. Breccia is a mixture of angular rock fragments, including pebble-sized pieces. Again, the main component is the mineral quartz. Sandstone is made of sand-sized quartz fragments and has an especially wide range of colors. Greywacke is made of angular or poorly sorted sand-sized rock fragments. It contains predominantly quartz, but some feldspar and clay minerals may also be included. Arkose is also made of angular sand-sized rock fragments. At least 25% of the pieces are feldspar rather than the more dominant quartz. Fine-sized or silt-sized quartz fragments in compact layers form siltstone. Very fine-sized or clay-sized fragments of quartz and clay minerals form shale. Shale is most noted for its internal layering, or for the way it breaks in sheets. Cryptocrystalline texture chemical division sedimentary rocks are the most diverse. The quartz varieties are named for their colors. Light shades are chert and dark shades are flint. Less common are ones such as the red variety called jasper. If the composition is calcite, then the rock is lithographic limestone. Crystalline texture, the most common of the division, is limestone. To be more descriptive, the texture can precede the name, such as crystalline limestone. This is how it works with the oolitic texture, making the rock of calcium carbonate or calcite called oolitic limestone. Let us examine some samples of each of these. Chert is cryptocrystalline quartz in various light colors. Flint is cryptocrystalline quartz when it is dark colors such as dark gray to black. Cryptocrystalline quartz in shades of deep to bright red is jasper. Cryptocrystalline calcite in light to dark colors is lithographic limestone. Slabs used to be used in printing. Limestone, or crystalline limestone, is intergrown crystals of calcite in various colors, commonly from light to dark gray. Oolitic limestone, made of oolites, or small spheres of calcite cemented together in a calcite matrix, may be light to dark in color. Organic division sedimentary rocks have a fossiliferous texture. Fossils of calcite compose fossiliferous limestone, coquina, and chalk. Fossiliferous limestone is limestone containing many fossils. Coquina is made of shell fragments and loosely cemented. Chalk is composed of microscopic calcareous organisms. It is smooth, white, and feels gritty. Diatomite is made of the shells of microscopic organisms that are composed of quartz. It feels smooth and is lightweight. Bituminous coal is black, burns, and is composed of carbon. It has a light weight and is made from partially decomposed plant remains. Let us examine some samples of each of these. Fossiliferous limestone is composed of many fossils held together by a calcite matrix and can range from poorly to well cemented. Coquina is shell fragments loosely held together by a calcareous matrix. It might be compared to looking like a granola bar. Chalk is white and composed of microscopic calcareous fossils held together by a calcite matrix. It is soft and has been used to write on blackboards. Diatomite is white and composed of microscopic fossils called diatoms that build their hard parts from the quartz dissolved in the water in which they live. Their shells have many holes, so this makes the specific gravity low. These tiny shells are held together by a quartz matrix. Bituminous coal is partially decomposed plant remains, so it is black, burns, and composed of carbon. It is an important energy resource. These are the major sedimentary rocks. Sedimentary rocks are the rocks most likely to be found at the surface, and they form at or near Earth's surface. To identify a rock, the first step is to determine the texture. What is this rock? Individual crystal surfaces that light up as the specimen is turned are visible. Fossils, oolites, or rock fragments are absent, so the texture is crystalline. The second step is to determine the composition. The specimen is soft and will not scratch glass. It will effervesce in dilute hydrochloric acid, thus it is composed of calcite. The crystalline texture rock composed of calcite is limestone, or what may more specifically be called crystalline limestone. This demonstrates how texture and composition are used to identify sedimentary rocks.